This is Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada, at my desk. Mr. Ladyada on camera control, video control, and trying out a new setup so the camera might look a little bit
With,
different.
yeah, it's better. With my assistant baby.
Baby,
Yeah.
uh,
So yeah, we better green screening, better audio, better lighting, better everything.
but
They say a lot of things change when you have a kid. Your AV setup could get better. Usually
yeah.
it doesn't happen, but in our particular case, it did.
All right. Well, do you have any news, or do you want me to just jump right
Regular
into?
shows and everything all this week. We'll be doing show and tell and ask an engineer. We have a ton of content coming out, so keep the dial on the thing with dials.
All right.
Yeah. What you got going on this week?
Okay, let's go to the overhead. I'll show some of the hardware I'm working on. So I finally got around to writing test code to verify that the um, PiCowbell Ada logger that I designed a couple months ago is working. So this is a Raspberry Pi Pico, and want to make some accessories for it. So this is, let me unplug this. This is a data logging like add-on cowbell that has a micro SD card, 12 millimeter coin battery holder, a real-time clock, the PCF 8523, which is like kind of one of my favorite real-time clocks because it works pretty well. It's very low cost, works with 3 or 5 volts, and has battery backup capability and a STEMMA QT port. So you can see it pretty much just exactly fits in this space, which is kind of sweet. And the SD card sticks out a little bit, makes it easy to grab. So the code example that I wrote writes the looks to see if you have a BME 280 plugged in, and if so, it takes the temperature, humidity, and pressure from that. If not, it just takes the voltage from the analog voltage ADC, which should be like it should be 5 volts. It measures VSIS and the onboard temperature and the time and date, and it logs it to a file, and it logs it to a new file. So let's plug it. Oh, is it not focused? Oh, you're right. It's not. There you go. There you go. Sorry about that.
High resolution stuff.
Well, I'm learning how to use the. Now I'm using this other overhead. So when I plug it in, well, first off, I plug it in if I don't have the SD card inserted. It blinks because it's like, hey, I need an SD card. When you insert the SD card, it then logs data every 5 seconds, and then it flushes the data to the SD card that it writes, and it writes a CSV. And that's important because if you don't flush the data, data is cached on the SD card and within the file system that Arduino uses. So it's important to write. And then when we write, we have the LED on, so you can safely unplug it whenever the LED is off, which is 98% of the time. Just don't plug it in don't unplug it exactly when the LED is on.
Okay, question. I have a BME 688, but it always seems to show 10 degrees too warm versus my wall thermostat. Any way to recalibrate it?
We actually have a guide on calibrating temperature sensors. The BME 280 has a heater inside of it, which is probably what is happening. If you're using the gas sensor, it self-heats. That's the whole point. It has to heat up the MOX plate in order to perform the gas sensing. So the temperature sensor is actually on the BME 68 series is not super great for actually measuring ambient temperature. You'll want a different temperature sensor and keep the BME 680 or 688 for measuring gas and humidity and other environmental stuff. Okay, so now that we've logged data for a little bit, I'm going to let it do one more. And then I unplug it. And then let's look at the SD card on my computers. Give me a second and I'll load it up and then I'll tell. Okay, so if you go to my computer, oh, weird. That's not my computer.
It's not.
No, that's a screenshot of my computer. Do you want to try to debug that real fast, or? I mean, it's kind of cool.
Yeah. What is it?
I think it's frozen. Yeah, it's from before. That's the board I was designing, which is super cool. But so basically, this is very similar to the data logging. No, it should be like a Windows desktop.
That's a little bizarre.
That is a little bit bizarre.
All right, well, keep chatting while I
Okay.
see what's going on.
Well, I actually show the layout, which is here, coincidentally. And the code that I'm running is the same code that is from the data logging shield for Arduino. So what it does is when it starts up, it looks for files called like adalog00.csv. And if that exists, it opens up 01.csv, et cetera, up to 99.csv.
It keeps bringing in just the same exact screenshot.
That's
Yeah.
very
Where
weird.
in the world?
Yeah, I don't know.
Yeah.
Huh.
Well, keep going because I'm
Okay.
gonna
Well, how about
keep chatting because I'm going.
well, let me skip ahead and I'll go to the next thing because and then if we get the computer going. So can you go to the overhead? I'll show
Yeah.
the Einstein hacker stuff. Okay. So the other thing I worked on is wanted to keep going on the hacking the baby toys. This is the baby Einstein play along tunes or take along play tunes. And so you remember we removed the guts of this and it had like an epoxy blob chip. And I kind of started like scanning stuff and designing and thinking like, okay, what, um, oh, hold on.
What's up?
No, just it flickered, but I want to make sure it was okay. Sorry. So I designed, so I was going to design a new circuit board that uses the ESP32 S2 as a processor chip that would replace what was in here before. And nope, still.
It's pretty amazing that it somehow saved that.
Yeah, weird.
Yeah, that's all right. I'm gonna keep going.
Yeah.
We will,
Well, let me just check real fast what my if it says it knows that there's a display. Yeah, it's like there's a display and
all right.
duplicating. Yeah, I think so. Whatever.
That's all right. I will.
You're gonna figure this out.
Ideas.
You have ideas. Try flipping the USB-C the other way.
Yeah.
So to prototype that this stuff will actually work, because I actually haven't played audio files on an ESP32 S2 through I2S. I had Jepler actually verify this, but like having someone verify and then I want to also verify. So this is a QT Py ESP32 S2. And the S2, like a lot of people are like, why don't you just use the S3? Isn't it better? Well, I find the S2 to be more stable for like almost all purposes. And the S3, like even over the weekend, we had to debug a thing where the S3 doesn't boot out. There's like some JTAG USB thing that causes it to not reset all the time. No,
It
still.
permanently likes that.
How does it? That's weird that it.
Yeah, no worries.
Yeah, who knows?
So
You have more ideas.
I will continue to debug this.
Sure. So one thing I wanted to take advantage of is I have these pads on the top of the QT Pies, like all but the first one. So you can have battery input that is separate than it's diode protected from the USB. So if you want to do projects like this where you have like USB, but you also have like a battery input, use those pads. And then I had actually JP try this when he did the CNC. And it turns out, like, even though, like, kind of sort of technically you could run all the circuitry off of the 3 volts coming out of this 2 battery pack, sometimes people use rechargeables and then it gets down to 2.5 volts, and that's like really quite low. So even though this, you know, if it was the freshest alkalines, it would probably be good enough to run the circuitry. I use the TPS 61023, which is like a really cute 5-volt boost converter. I might actually change this to be a 3-volt boost converter later, but the 5 volts does work pretty well. And that way you have a lot of headroom from the diode into the 3.3 volt regulator. So it's not a bad idea. That way you don't feed into the 3 volt, you feed to the regulator. It's not as power efficient, but that's okay.
Amazing.
It's still the thing, huh?
Yeah, it's all right.
Mm.
We keep
I'm gonna keep trying things. Okay, so they get the little boost converter, the TPS 61023. And then here's the 5 volts going into here. And then this is the new board. So this is the I2S BFF. It's a little add-on board for the back of a QT Py. And I think I showed this off last week or 2 weeks ago that I designed it. It has a max 98357 and you would have a couple passives and then a Molex Picoblade connector.
That's
Oh,
right.
yay!
I will never give up. Ever.
Never give up.
I will
Never
up
give
on
in.
anything ever. This is it's a flaw, and it's
It's a blessing.
Man.
Okay. All right, so we're gonna pop the stack. We'll get back to interrupt back in. All right, so this is that SD card from the data logger. Like I said, it creates a new file each time. So you see this one 630 bytes because I ran it overnight. This one is the one that we just ran, and also like I had a bit of a typo where had the Ada low 010 instead of Ada log. But let's open this, and so the demo code that I have right now basically just saves a CSV, and you can see like this is just the data that it logged while we were hanging out. Pretty straightforward, but what I like is the the time. You see it was 9:03. This is a live show. No, it's 9:12. It logged properly and it started up correctly with the right time. So basically that's my demo. Like, if that works, and I run off of battery as well, without plugging to USB. So now that this works, I'm ready to send out the board. And the last thing I do is I just do the silk screen. And Phil not only never gives up on AV stuff, but also gave me a wonderful logo. Never give up, never give in. A wonderful logo that is like the cowbell logo. So we're gonna have that on the back of boards, and then I'm reusing the Italogger logo, and then I'm just going to clean up this little text here. It says PiCowbell, and this is non-rendered text, and then, oh, sorry, and then this is the top silk again, which you saw before, but now wait, I've disappeared.
Yeah, you're fine.
Okay. Oh, they don't see me. Sorry, never mind. I'm learning this AV. Yes, top right is what they see.
Yeah.
Silk screen's pretty much good to go. I added a pull up on the CS line. One thing that I did look at really briefly, just because I know somebody's going to ask, is like, hey, can you do SDIO on that card? And the answer is like, not really, kind of, because the pins that for SPI that are the default pins of Arduino, which is what I want to use, aren't in the correct order to allow me to add more pins to make it SDIO. So for now, I'm just going to have this be only SPI mode for the memory card. And then we'll go back and do SDIO maybe later, or we'll do a special edition because it won't use the default SPI pins. And I feel like I'd rather make it easy for people to get going with SPI than make things complicated for like the 5 people who would use SDIO. And for data logging anyways, SDIO is not that beneficial. Because the speed is dictated by the flash erase speed, not the and write speed, not the read speed. So SDIO is most useful for fast playback, not recording. Okay, so then so that's done. I'm gonna actually send off those boards. We'll get that into the shop soon. Oh, I also added some mounting holes. They're not in the same place that the Pico has mounting holes because they don't really fit, but allow me to do the testing easier. Okay, what's a
Couple questions.
no question?
Because I had to do an AV detour.
Yeah.
So 2 questions. Um,
Yes.
yeah, just hold on. There's a bunch.
Oh boy.
Well, there's a bunch of scrolling because I have to go back.
Never give in.
Someone in the forum was asking about an adapter to use feather wings with QT and I was thinking that it could take the form of a feather doubler or tripler with a QT slot connecting to I2C, SPI, UART, and some pins, maybe with jumpers. Okay, that's not a question, of the statement, but you probably have a comment on that.
Yeah, it's just tough. I think the boards, you could adapt them, but it's never quite,
Okay.
easy.
Next up, do you have a favorite microcontroller? And then the other one was, what's the difference between SPI and SDIO?
Favorite microcontroller here is the RP2040 because I'm looking at it right now.
The one you can get.
The one you can get, and then I don't have like favorites. I kind of like I like a lot, and so what's the difference
between SPI and SDIO?
SDIO is a just faster protocol that uses way more pins, but they have to be consecutive. It's like a 4-bit bidirectional protocol, whereas SPI is, each pin has only one direction, and it's kind of more universal. So SDIO, not all. I mean, there is RP2040 support, but it's not with PIO, but it's not excellent.
Okay. You want to do great search?
Well, let's go to the overhead because I have to go back, finish the thing I started, and then we'll go to great search because it'll be perfect timing. So then I've got I didn't leave this plugged in, so I don't know if it's going to work, but so I have the I2S, so I plug this in, and then the speaker. This is the original speaker that came with the board. So like, I'm just kind of playing around with, will this drive the speaker and what does it sound like? Let's see if this works. The only thing is I was messing with this. So oh, right. I have to press the button. So I made it so when you press the button, it plays the audio file. So. So that's the chicken dance song, which I think JP wrote. I actually don't know who wrote the song. We use it as a demo for all of our audio clips. So it sounds really good. And this is with half volume because actually full volume was too loud and I didn't blow out the speaker, but it sounded a little crackly, which sort of, it's overdriving the speaker. And also it was a little tough on the batteries. There was some voltage dipping, which caused a brownout. So the good news is that wave playback works. I'm playing the waves actually off of the onboard flash. There's about a megabyte of space, which is, for a kid's toy is plenty of wave file. And it sounds really good. And I2S doesn't have any clipping or ticks from under over buffer flows. So this is good. So this combination, the TPS, the QT Py, the I2S to the speaker is a good combo. So yeah, I already started designing the hardware, but I wanted to verify it before I kept going with the design in case like Wave or I2S playback didn't work on the S2, but it works just fine. Any last questions before we go to Great Search?
Nope.
Okay.
Where in the world is that part I need? The Great Search with DigiKey.
Every single week, Ladyada uses her power of engineering to help you. Yes, you find all the things you want online at digikey.com. Ladyada, what are you looking for this week?
Okay, this week, so let's go to the overhead and I'll show what I was just showing, which is hacking this electronic kids toy. And I'm plugging in an I2S amplifier into my ESP32 board to get nice quality audio, which I'll demo again. Okay, so the ITS audio sounds really good. The speaker sounds really good. It runs off of rechargeable batteries because I'm using a boost converter. Everything's great. And the connector that I'm using on this board is a Molex Picoblade. And I realized I hadn't covered Molex Picoblades before on the show, and I wanted to show them off. And so let me demo why you'd want to use a Picoblade. So this is my, hold on a second. Let me grab, I've got okay, so I've got like a funhouse board here. So this funhouse board has JST 3-pin connectors on the side, and also has a stemma QT. So the stemma QT is JST SH, which is not a bad connector, but a very common connector you're going to see in the real world is the 1.25 millimeter pitch Molex Picoblade, and what's nice about it is the Pico is a fine word to use for it because you can see how thin it is compared to this JST PH. It's a very skinny connector, but it's nice and solid. It's from Molex, and they make really good stuff. The blade is because the contacts actually, if you look carefully, they're kind of bladed. They're not pins, they're flats, and that actually makes them also much more durable, especially if you have like a lot of cycles connect and disconnect. They don't bend. I've never had a Picoblade bend or crack on me. I have had pins on other connectors, that if you don't get it quite right, something catches, they'll bend inside the contact. These don't seem to. Another thing I really like is that there's this little cutout here so you can see that the contacts are there and straight so you can, before you connect something. And then this is the contacts, which is the sockets, which go into, in this case, the speaker. So let's go to the computer. So like I said, they're called Molex Picoblade. Now, one thing I noticed while searching is that there's actually, well, first off, DigiKey changed their front page, so check that out. New products is kind of nice. It's what I use for INMPI. So Molex Picoblade. Okay, so there's a lot because there's going to be cable assemblies and there's going to be connectors. So we want to go to header male pins because that's what goes on the PCB. And, let's say we want 2 positions, active, and surface mount right angle because that goes out the end. And let's just say in stock. So yeah, these are some of the contacts that you use. What I like is that it's like you only get 3, and the 3 are all slightly different. So this is the series, the 53261. This is the this is what I tend to use. This is the tinned version. You're feeling fancy, you want gold plated contacts. They're more expensive, but they will resist oxidization more. And then there's also a nice 360. And they did a really good job getting a lot of photos of this so you can really see all the contacts. I can see like nice thick contacts here. That blade, again, a lot of mechanical stability over here. And then I really like, hold on, the detail here. Let's see, let's zoom in. A lot of mechanical stability. Again, I've never had these fail or pull off. They're really, really solid connectors. So this is the part I recommend using. I mean, you can use the gold plated one or you can use the silver, the tin plate one. However, you probably also want matching cables to go with it, which you can also get. So if you click on the series, that'll take you to like everything in that series. So you're like, oh, I want like 5 pins or 6 pins. It'll give you everything in that series. And then you could also go to Molex Picoblade and search for cable assemblies, which I always recommend. So you can, get, oh, let me show you one more thing, sorry. In addition to, you can click on that. If you go down to the bottom here, you can find, under featured product, if they featured it, what's really nice is they have like this kind of descriptive text that tells you about it. Not all products have this, but like most large series of products do. So in this case, it kind of tells you, what it's used for, 1 amp of current, which is a lot. Again, that's, compared to JST-SH, which I think is like 340 milliamps. So it's quite a lot of current, which is why I really like it for speakers. You can get contacts, connectors, housings, and then crimpers. If you are going to do your own cable assemblies, get the official crimper, or get like a really nice like engineer crimper. Don't use a pair of pliers because otherwise you're gonna be sad. You're not gonna have a good time if you don't have a good crimper. But if you don't want to crimp, I do always recommend getting pre-made cable assemblies. They're not that expensive, especially, considering you get them the next day. And then of course, when you go into production, you can either use the pre-made assemblies or like contact your cable house and they'll make you Picoblade connectors with any combo. But what's nice is that like, any number of circuits, almost any length. So, say we want a 2-pin cable, and let's see what's available here. 450 millimeters, 150, 100, little extendos, very handy to have these little extenders. 450 millimeters, and then just pigtails if you need them, and socket pigtails and plug pigtails. It's actually another interesting thing about Picoblade is some cable systems, again, like the JST-SH. I don't believe it. I've never seen JST-SH free hanging. But what I like about Molex Picoblade is that they have PCB mount, vertical, right angle, and then cable connects, and then they have free hanging connects as well. So again, you can do the extenders, or you can just have, like, if you want these for free hang. I really like that this cable series for that reason. And again, like compared to the JST, PHEs are much smaller, but they can carry a lot of current. Good for wearables, LEDs, speakers, like AV stuff. While this whole series is my my pick, this particular product would be my choice for the Great Search.
And that's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
Okay, a couple more questions that came in. Is it common for color options to be random? I've noticed many Adafruit products with JS connectors have a notice the connector color may vary.
Yeah, sometimes we get black ones, sometimes we get tan ones. Those are the only two colors though.
Yep. And then we were asked a question. I answered it in the chat, but I'll also mention it here.
Yeah.
Folks love the Cowbell logo. Can they use it in their open source designs? The answer is yes. Just email pt@adafruit.com. I will set you up with everything.
Yeah, we'll publish that as well.
Okay, next up. What code editor does Ladyada use? Should I stick with KiCad or Linear Eagle? I know Eagle is considered more professional, but is worth the cost-free plan limitations.
Totally doesn't matter. Use whatever you want. All of them have similar functionality.
What code editor do you use?
I use Xemax, but sometimes I use Atom if I'm doing Python.
So a little bit of maker history.
Discontinued.
I've mentioned this on our other shows and more. Back in the day, there was a meeting that Ladyada and I did along with Wendell and Lenore from Evil Mad Scientists. We met with EagleCAD folks before it was acquired by Autodesk, and we convinced them to have XML export. So one of the reasons you can still move things around between KiCad and EagleCAD is because we convinced them that this was a good way to grow a big community of people doing electronics to get it.
You can really parse it XML, like the Penguin, the font stuff that we do for all of our boards. Phil B wrote that in Python, and it just uses the raw XML. Like it creates a package with raw XML and just like shoves it into the file.
And
it's just pretty neat.
As far as we're concerned, because we're the #1 certified open source hardware company. If you look at the numbers, so does it matter what tool you use? Absolutely not. We're going to be the ones to always say that. I know there's purists who say no, you have to use entire open source tool chain. Well, guess what? That's still not going to be good enough for some people, because maybe you use Windows. Maybe you use an elevator to get to your office, and the firmware in the elevator is not open. Someone said that Adafruit will never be open source because Ladyada takes an elevator to her desk, and that elevator is not open source. I shit you not, folks. This is a purity test that you got to stay away from. So the only thing that matters is you publish the files in the format that you made. So there's open source with Altium. There's open source with KiCad. There's open source with Eagle. It's all about sharing whatever tool you use.
I sent one link to and somebody was published. People publish people just publish their schematics in ASCII in how-to files.
It's totally okay.
That's fine.
And the folks who get hung up on this, they're not the ones that are publishing stuff anyways. They just want to be like jerks. So don't ever worry about that at all. Use the one that you want to use, and use the one that you use the most often and get the most out of it.
All right.
And that is our show tonight. Thanks everyone for hanging in there. I'm pushing the limits of USB-C.
What was it? Was it just?
I think computers just get confused when you have this many video things going on.
Okay.
And it decided to save that
yeah,
that screenshot. It worked. So all right.
Okay.
See everybody during the week.
Bye everybody.